Hi, friends and my dear students. Today, a very interesting topic and famous scientist, the world famous scientist Mr. Einstein, theory of explanation about photoelectric effect. Actually, he got Nobel prizes for this explanation of photoelectric emission and the equation what he gave E equal to mc square. Such a famous scientist's explanation that we are going to see. Now, we shifted over to the topic particle nature of light. We already studied about particle nature of light as per Maxwell and another scientist and Planck. Everybody gave their own theory and their result. But as per Planck suggested that in last class we have seen that as per Planck, light is nothing but the energy of light is exhibited by means of quanta, that is called quanta particle, or yeah, packets of small bundles of packets likewise. But Einstein want to explain the same photoelectric effect. That's why he extended his Planck's theory to explain the photoelectric effect and his own methodology. That's the thing that we are going to see today. Now, according to Einstein explanation in the year of 1905, he considered light is light is light or any other electromagnetic waves, whatever it may be, electromagnetic waves are propagated in the media only in the wave form, not as a wave form or wavefront, but not that is called wave, not like waveform, but only by means of particle or quanta, or an energetic particle. Energetic particle. This is the fundamental phenomena that he want to explain in this experiment. Light is exhibit an energy, right? Many scientists already proved that favor to the photoelectric effect either or diffraction interference in some other experiments, both wave theory as well as electromagnetic theory, uh, wave theory as well as particle theory. But according Einstein explanation, first he gave his valuable point. Light is or electromagnetic waves is traveled through the media not in the form of wavefront or waveform, but a particle or like a quanta or energetic particle. That's a very important concept. Initially, he started. So what? The small packets, according to his theory, light is emerged in the media just like a small quantum particles or bundles of small packets with energy. If you consider a single ray of light, you consider a single ray of light, then each and consider one quanta. Then the energy of the quanta or the electromagnetic energy of the quanta, whatever it may be, is only depends on particle theory. Depends on particle theory, not on the wave theory. That's his initial idea to explain in this concept. Okay, suppose what he told, energy of light spread in the media only in the wave fronts, but is connected with a small packets or energy quanta. I already told. Now let us assume any sources any sources which are giving new frequency, the radiation of the outcoming from the source of having new frequency, the energy are radiated like this. If suppose, if you consider this beam of ray, or this is called a beam of ray, and each and every quanta has its own energy, and this energy are transmitted in the media only in the particle waves but not in the wavefront. That's his concept. That's his concept. For example, if you consider source, there is the ray which are emitted through the source, and the frequency of the emitted radiation is considered to be nu, then the energy of this quanta, each and every quanta are explained in the same equations. Energy E equal to h nu. E equal to h nu. This is the fundamental equation he gave. The energy of this quanta is nothing but h nu. From this equation, we conclude that the energy Planck is a constant. Planck h is a constant. So the energy of the quanta, which will depend on the frequency, but not with intensity, not on intensity. The energy of the quanta of beam or energy of quanta of any ray, which will depends on the frequency but not depend on the intensity of the instant radiation. That's a very important concept. So he gave a valuable equation E equal to h nu. Here h is Planck constant, nu is the frequency of the emitted radiation from the sources, whether it may be light or whatever it may be the ray. Now, and he added his another valuable point. This energetic particle or quanta will have or possess linear momentum. Linear momentum. Linear momentum. And this linear momentum P equal to h by lambda, or P equal to h nu by c, whatever it may be. Since c equal to nu lambda, if you can modify this equation like in another way. Suppose if you are giving the value h nu by c, or in some other way, lambda, that is equal to lambda, sorry, nu by c, that is equal to 1 by lambda. Are you clear? You bring lambda this side and c on that right hand side. What will happen? Then nu by c equal to 1 by lambda. So that we can write the linear momentum of the equation h, h by lambda. H by lambda. Nu by c or likewise. Suppose you substitute the value of lambda. What is the value of lambda? Nu by c. Suppose if you are putting here mu by c, then c is in the upper, hc by lambda. Either this way or this way you can write. This is called linear momentum. In other words, if you want to clearly understand, then consider c equal to nu lambda. In case this, you can write, bring this right hand side, the wavelength is soluble, you have to bring this wavelength to the left hand side, then what will be happen? Lambda equal to nu by c. This value of 1 is substituted here, then we get h nu by c. In other words, you can modify this equation likewise. This is called c equal to nu lambda, nu by c, nu by c. We can write nu by c is nothing but 1 by lambda. 1 by lambda. That's the way of method, but in your book there is only one equation are given, you don't confuse yourself, but the linear momentum P equal to h nu by c, that's all. P equal to h nu by c, and c is nothing but c equal to nu lambda. This was explained by the Einstein. Now, we have to think about the individual quantum. When you consider individual quanta of any beam or any ray which define energy as well as momentum associated with the particle. That means this quanta consisting of energy along with momentum and associated with the particle, so that this is the particle theory. Are you clear now? It is nothing but the quanta is nothing but an energetic particle, and it possesses linear momentum as well as energy. So that we conclude that the light quantum, the light quantum, light quantum means or quantum, light quantum. What is meant by light quantum? When you consider a ray, there may be a tiny particle, it is called as light quantum. This light quantum can behave as a particle theory. When you consider a quanta particle, then it behaves like a particle theory, not as a wave theory. When you consider light quantum and the quantum of light particle is behave as a particle theory, but not favor to the wave theory. Therefore, and these particles are said to be energetic and simply called photon. Photon. This is called photon. Light is nothing but quantum particle or particle that was possess high energy as well as linear momentum, so that it was called as a energetic photon particle. So light rays is nothing but constituent particle of photon. That's all. Constituent particle of photon. Light is made up of many constituent particle of photons. This the famous concept that was explained by uh, Albert Einstein. Albert Einstein. Or we can say like that in some other words, therefore, the photon is nothing but particle manifestation of light. The photon is nothing but the particle manifestation of light rays. That's all. This is very, very important basic concept that he need to explain the photoelectric effect. Okay, are you clear? Then, when we go through this, the photon energy, then according to the particle theory, according to the according to particle nature of light, according to particle nature of light or quantum nature of light, photons are basic constituents of the radiation and possess the following five important characteristics. Five important characteristics. That is, we are going to see one by one. One, two, three, four, five. According to the particle theory of light or quantum theory of light, whatever it may be, it possesses five important characteristics explained by the scientist Albert Einstein. Albert Einstein, that we are going to see one by one. First property. First property, if or the photon light of frequency, let us consider a photon of frequency of nu and wavelength are said to be lambda. Are you clear? Now let us consider any photon of given frequency nu and the wavelength of the photon is considered to be lambda. Then the energy of the photon is given by the equation E equal to h nu. E equal to h nu. I already told C equal to nu lambda. If you want to find out nu, then C by lambda. C by lambda. Are you clear? Therefore, E equal to, instead of h, you have to put the value of C by lambda. This E equal to h nu or hc by lambda is the energy of the photon. This is called energy of the photon. Either you can write like this way or this way. Both are the energy of the photon. It was explained on the basis of frequency as well as wavelength, both, but not depend on the intensity. That's a very important concept that you have to clear. The photon energy which will not related with the intensity on any occasion, on any moment, according to Albert Einstein as well as Planck. Now, the second important property. The second important property. The energy of photon is determined by the frequency of the radiation and not by the intensity. The energy of the photon is depend on the frequency, not depend on intensity. That's very important. The energy which was emitted during the process or whenever any rays or light rays or electromagnetic rays outside from the source, then it possesses photon or particle, anything else, it possesses energy which will depend on frequency but not depend on the intensity. This is a very, very important concept he assumed. And also, if you consider any beam, then each and every photon has its own energy, and it was each and every energy which has its own energy and was explained by the same phenomena. There is no electron available here, depends on the intensity. All the photons available in the beam which will be depend on the frequency and not depend on the intensity. That's a very clear concept. You have to clear yourself. And third one, if suppose the photons travel with velocity of light, let you assume photons, if travels with velocity of light rays, photon, it travels with velocity of light rays, then it has a linear momentum. I already told. Then the velocity of light and its momentum, the velocity of light and its linear momentum is given by the equation, is given by the equation P equal to hc by lambda or h by lambda. H by lambda, if you are substituting the value of 1 by lambda, if you want to find out here from this equation, you want to find out the lambda, 1 by lambda, then you have to bring here. What happened? Nu by c equal 1 by lambda. Are you clear? So instead of 1 by lambda, you have to put the value of nu by c. Then pu nu by c. That is, it means that if any photon travel with velocity of c as well as it possesses a linear momentum and depends on the frequency, not depend on the intensity. That's a very important equation he gave to explain this concept, and also linear momentum. This is a very important equations for the linear explanation of the linear momentum. This one is third. Fourth, if you consider fourth point, photon, photon is neutral particle. There is no charge. No charge. Suppose now I have to consider two electrodes. One is positive and another is negative. There may be an electric field or electromagnetic field, whatever it may be. Here, when you allow to move these sources are here, if you the outcoming rays are allowed pass over through this in between this metal, the path of the ray which will not be affected. The path of the ray which will not be affected. It means that here there may be an electric field, and this electric field which will not affect the path of the ray, so that the photon neutralize the particle or no charge. That's why the path or travel in the straight line manner only because of neutral particle. It possesses neutral particle and not any charged particle. That's why it will not affect by the electric field. In another, if suppose you have to consider north pole of the magnet and south pole of the magnet, likewise, then you allow to pass the same photon ray, then again the path of the photon which will not be affected. Here, instead of electric field, there may be a magnetic field. This magnetic field also not affected the path of the photon. That's why only because photon is considered to be a neutral particle. There is no charge. So that we conclude photon is a neutral particle. That's why it will not affected by either by electric field or by magnetic field. That's an important concept of fourth characteristics. And the last one, very important and very easy. When the photon interacts, let us consider photon or collision which are happen or with any matter. Suppose here are matter, then photon are here. If it is hitting the matter, what happened? Something will happen. Now listen once again. This is the outcoming ray from the source. Here there is a energetic particle of photon. Hit the, for example, let us consider this is called electron. This is called photon. Photon. Photon hit the matter that is called electron. What will be happen? Here the total energy or linear momentum or angular momentum which will be conserved. Which will be conserved. There is no change. There is no change. So that, but here one thing you have to, during this process of hitting the photon on matter or on electron, it may produce some other photon equal in energy to the hitting photon. But the number of photon number of photon may not be explained, may be modified, may be இங்க என்ன பண்ணல, it's not a constant. The number of photon may not be constant, may not be unchanged. That's a point which are not accepted by the Einstein, and he conservation of, we can't give the conservation of number of photons. It may be modified. It may be modified. Whether it may be number may be reduced, Likewise, he gave his valuable 5 important characteristics of this characteristics as explained by the Einstein theory. This is a fundamental theory that he needs to explain this photoelectric effect. You have to think clearly. I hope you may understand the concept in easy way. Next class, I have to explain Einstein explanation of photoelectric equation clearly. Thank you, friends. Subscribe my channel and refer your friends and click all bells. Thank you.